These next couple examples are all about compound volume problems. So we're going to either be putting things together, taking things apart, or looking at multi-steps to a problem. So Tanya uses cube-shaped beads to make jewelry. Each bead has a circular hole through the middle. Find the volume. So really we have a cube that we're starting off with, and we're going to be taking away this cylinder that's going down through the middle. So let's focus on the cube. It's actually a type of rectangular prism, which means our volume is length times width times height. The length, the width, and the height are all 12. So our volume for the cube itself is 1,728. If I'm looking at the cylinder, it's going to be BW. So off to the side, we need to do B. The base is a circle, which is pi r squared. All the way across is 2, so my radius is 1. So our base is 3.14 times 1 squared, which is really just 3.14. And my W is what connects the top to the bottom, which is the same thing as the height of this cube, which is 12. So my volume of my cylinder part is going to be 3.14 times 12, which is 37.68. So now all I do, 1,728 for the cube minus 37.68 for the for the cylinder, get 1,690.32 millimeters cubed. Next one is about an unused roll of paper towels. What's the volume of the unused roll? So again, in this one, we have the outside cylinder, and we're going to be taking away the little inside cylinder because that part is not filled with paper towels. So, volume equals BW for the big one, and volume equals BW for the little one. So, for me to do this, for the big roll, it's 14 all the way across, so my radius is 7. So B equals pi r squared, which is going to be 3.14 times 7 squared, which will be 153.86. And for the big one, the W is the whole thing, what connects them, so 28 centimeters. So 153.86 times 28. So for the big outside part, we're talking 4,308.08. For the little inside part, the B is pi r squared. All the way across is 4.5, so my radius is 2.25. So 3.14 times 2.25 squared. This one we're going to have to round. So with 15 point, we're going to go 9, because 8, 9, if I round it to the nearest hundredth, I'm going to end up rounding to up to 90 anyway, so 0.9. So my volume for the B for the little one is 15.9. W is still the same, 28, because that runs the whole way. So 15.9 times 28 is 445.2. So I'm going to take 4,308.08 minus 445.2. Oops, I missed a decimal. 0.08 minus 445.2. Get 3,862.88 centimeters cubed. This one says, which one's going to hold more cake batter, the rectangular pan or two of these round pans? Explain your reasoning. So if I'm holding more, I'm filling, which I'm talking about volume. If it's rectangular, remember we can just do LWH. So 13 times 9 times 2. So 13 times 9 times 2 is 234 cubic inches. For the round pan, I have V equals BW. So off to the side, B equals and W equals. W is easy, it's what connects them, it's the 2. Base is a circle, so it's pi r squared. All the way across is 8, so my radius is 4. So B equals pi times 4 squared. Which will give us 50.24. So my volume for this circular one is 50.24 times 2, which will be 100.48. Remember, it says I'm using 2 of these, so times 2, which would be 200.96 cubic inches. So which one holds more? Definitely this guy, because it has higher volume. So it's holding more. Take a look at next one. You're filling up this container a quarter of the way full with cotton balls to dump on Mr. Towers at the end of the dance marathon. What volume of cotton balls do you need? So our height is actually only going to happen here, which is a fourth of 12, which we actually know is 3. So my height here is only 3 feet. I'm not worried about the rest of that. It's a rectangular prism, so I can do length times width times height. So 6. This is 2 down here. Bring it down from the top, times 2, times my height is 3, which will give me 36 cubic feet of cotton balls. Now, it says you put all the cotton balls into the container in 3 minutes. What is your rate at which you are doing it? So rate would be cubic feet per minute. So we have 36 cubic feet, and we did it in 3 minutes. So 36 divided by 3 is 12 cubic feet per minute would be your rate then. Last example, Robert's family uses a container shaped like a cylinder to recycle aluminum cans. So here's my cylinder. It has a height of 4 feet and a diameter of 1.5 feet. So if I know that, my radius then is 1.5 divided by 2, which would be 0.75. I'm going to need to know that. The container is full. So basically it's full. So volume equals BW over here. B equals, it's a cylinder, so the base is a circle, pi r squared. It's 3.14 times 0.75 squared. And that gives us, we're going to be rounding to the nearest tenth, so B is 1.8 then. I got 1.76625. My W is the height, which is just 4. So my volume is 1.8 times 4, which will be 7.2 cubic feet. So this is how much do the contents weigh if the average weight of aluminum cans is 37 ounces per cubic foot. So it's 37 ounces per cubic foot, which means 1 cubic feet. So we have ounces, cubic feet. We have 7.2 cubic feet, and we want to know how many ounces that is. So 37 times 7.2, 266.4. 1 times x is just x. So it weighs 266.4 ounces.